Hi guys, it's Mrs. Rooker again. Alright, so we're going to do 4.4a now. When you are given any one trig value along with where a specific angle terminates, then you can find all of the other five trig ratios. Look at the following and decide which special theorem you will need to use each time. So let's start this and then we'll go back and we'll talk about what special theorem we're going to use. You might already know. All right, so we're given a coordinate point. So -5, -12. All right, and then I am going to draw my line. All right, -5, -12. I'm going to create a right triangle using my x coordinate. So this is -5, and my y coordinate was -12. And then I need to find the other side of my triangle. In order to find the other side of the triangle, I am going to use a very famous theorem, which is Pythagorean theorem. All right, so Pythagorean theorem, I don't need to worry about the negatives when I'm doing Pythagorean theorem. 5 squared plus 12 squared equals c squared. This is actually going to be a special Pythagorean triple that you should memorize if you haven't already. 5 squared plus 12 squared should end up equaling 13 squared. So this Pythagorean triple is 5, 12, 13. All right, and now we're just going to find all of the ratios. So this is theta, or I guess we're dealing with A, not theta for these ones. A. This was A. Then cosine of A is adjacent over hypotenuse. So adjacent is -5, hypotenuse is 13. So -5 over 13. Oops, I said myself. -5 over 13. All right, sine A. Sine is opposite over hypotenuse. So opposite of A is going to be -12 over hypotenuse, which is 13. Tangent is opposite over adjacent. Opposite is -12. Adjacent is -5. -12 over -5 is going to be positive 12/5 because the negatives cancel. All right, and then secant is just the reciprocal of cosine. So this is going to be 13 over -5. Cosecant is the reciprocal of sine. So that's going to be 13 over -12. And then cotangent is the reciprocal of tangent. So 5 over 12 for that one. All right, so pause the video if you need to catch up on any of those notes. Now we're going to use that same strategy to do the next few examples. So if secant of A is 7 over 3, and A is in quadrant 4, find tangent of A. So I already know without even doing this that tangent of A, if it's going to be in quadrant 4, is going to be negative, because if tangent's in quadrant 4, it's going to be negative. A, smart, trig, class. Only cosine and its reciprocal will be positive in quadrant 4. All right, so secant is 7 pi over 3. So remember, secant is the reciprocal of cosine. And so cosine is adjacent over hypotenuse. This is going to be hypotenuse over adjacent. So adjacent is the x. So adjacent is 3. And hypotenuse is 7. And then we need to find what the opposite is. So that's what we need to find. We're going to use Pythagorean theorem to find what that opposite is. Oops, I didn't mean to erase that, sorry. Alright, so this is going to be a right triangle. I'm going to do 3 squared plus b squared equals 7 squared, because 7 has to be the c since it's the hypotenuse. So 9 plus b squared equals 49. Subtract the 9, b squared equals 40, and then square root that. We end up getting root 40 breaks into 2, 2, and 10, so 2 comes out, b equals 2 root 10. And then we can use that to find tangent. Remember, tangent is opposite over adjacent. So if opposite is 2 root 10 and adjacent is 3, then tangent is going to be negative 2 root 10 over 3. And I should put, actually I should have put in here that it was negative since it was going downward. It was negative. So the answer for tangent of A is negative 2 root 10 over 3. Now we'll do the same thing, but we'll find all of the trig ratios. So negative 2, 3. And then I'm going to draw that angle. Negative 2, positive 3 will be the sides of the triangle. And then this will be my A in here. All right, I need to find the hypotenuse of that triangle. So I'm going to use Pythagorean theorem. 2 squared plus 3 squared equals c squared. 2 squared is 4, plus 3 squared is 9 equals c squared. 13 equals c squared, so c equals root 13. And then we will use that to find all the different ratios. So this is root 13. All right, cosine is adjacent over hypotenuse. So negative 2 over root 13. You can't leave your answer like that because you can't have a radical on the bottom, so rationalize. We end up getting negative 2 root 13 over 13. A smart trig class, it should make sense that cosine is negative in that quadrant. All right, sine should be positive in this quadrant. Sine is opposite over hypotenuse. So opposite is 3, hypotenuse is root 13. Again, I need to rationalize. So I end up with 3 root 13 over 13 for sine of A. All right, tangent is opposite over adjacent. So opposite was 3, adjacent was negative 2. So we get negative 3 halves. And hopefully it makes sense that tangent is negative in quadrant 2. All right, and then secant is just the reciprocal of cosine. So originally for cosine I had negative 2 over root 13, so it's just going to be root 13 over negative 2. And I can move the negative to the top if I want. The negative doesn't need to be on the bottom there. More proper to have it written this way. All right, the other one was originally 3 over root 13, so now it's going to be root 13 over 3. And then cotangent is the reciprocal of tangent, so negative 2 over 3. All right, so that's it for this section. Pause the video if you need to catch up on anything. So now we're going to evaluate each trig expression. If you have your trig functions memorized, this should be really quick. If you don't, it'll take a little longer. If you don't have them memorized, you can refer back to your unit circle, but you should memorize these. So sine of pi over 2 is 1. And if you didn't know that, we could go back to our unit circle. Sine of pi over 2. Remember, sine is the y coordinate. Cosine is the x. So Sine of pi over 2 is 1. And then cosine of pi over 6. Cosine is your x-coordinate, so that's going to be root 3 over 2. Plus sine of pi over 6. So sine of pi over 6 is 1/2. Times cosine of pi over 2. Remember, cosine is the y-coordinate. So for pi over 2, the y-coordinate is 0. And then we just simplify. 1 times root 3 over 2 is root 3 over 2. And then 1/2 times 0 is just 0. So this is our answer. All right, the next one, same idea. You should have these memorized. If you don't, you can look back to your unit circle. I'm very visual, so I like looking at my unit circle, but a lot of these should be memorized. So sine pi over 3. So refer to the unit circle if you don't remember. Pi over 3, right here. And sine is the y-coordinate. So root 3 over 2. And then cosine 0 you should have memorized. That is just 1. If you didn't remember that, you should be able to get that by looking at the unit circle. Cosine of 0. So a 0-degree angle would be down here. And then cosine is the y-coordinate, so that's why it's 1. Sine of 2 pi over 3. So pi over 3 would be in the first quadrant. 2 pi over 3 would be in the second quadrant, but it still have a reference angle of pi over 3. So second quadrant, A, smart, trig, class. Second quadrant, sign should still be positive. A, smart, trig, class. So that should still be positive for sine. And then sine of pi over 3, since our reference angle is pi over 3, sine should be root 3 over 2. And then cosine of pi over 4 is always root 2 over 2. Again, if you didn't remember that, you could refer back to your unit circle. All right, now we simplify. 1 times root 3 over 2 is root 3 over 2. Plus root 3 over 2 times root 2 over 2 is going to be root 6 over 4. We multiply the tops and we multiply the bottoms. But we need common denominators in order to add these. So I'm going to multiply top and bottom of this one by 2 so that we have common denominators. This will now be 2 root 3 over 4 plus root 6 over 4. I can add those together under one as one big fraction with a denominator of 4, but since these radicals are different, I can't actually combine them, so it's going to be 2 root 3 plus root 6 over 4. All right, sine of negative 8 pi over 3. So this is definitely going to be one that I'm going to, I personally am going to draw a little picture so that I can see where that terminates. Negative 8 pi over 3 means I'm going clockwise. 6 pi over 3 would be 1 full rotation. But then I'm going to go 2 pi over 3 past that, meaning I'm going to terminate in Q3. A, smart, trig, class. So this is actually going to be negative in that quadrant. Negative, and then sine of pi over 3 is root 3 over 2. If you didn't remember what sine of pi over 3 was, use your unit circle. Sine of pi over 3, so your y-coordinate of pi over 3 is root 3 over 2. All right, now tangent of pi over 4. Tangent of pi over 4 is always 1, because sine and cosine are both root 2 over 2. And it's going to be positive since it's in the first quadrant. And then the next one, cosine of 7 pi over 6. So 7 pi over 6 is in the third quadrant. And since that's in the third quadrant and it's cosine, it's going to be negative because only tangent's positive. Tangent and its reciprocal are positive in that quadrant. And then cosine of pi over 6 is root 3 over 2. Remember, you can look at the unit circle. Cosine of pi over 6 is root 3 over 2. All right, now multiply negative root 3 over 2 times 1 is negative root 3 over 2 plus negative root 3 over 2. Add those together and I get negative 2 root 3 over 2. Reduce, I get negative root 3. All right. So pause the video if you need to catch up on anything on this section. All right, now I believe we are on the last section of the notes. And we are supposed to find the values of theta from 0 to 2 pi, so within one revolution, that satisfy each condition. So where is cosine of theta equal to root 2 over 2? So I'm going to use a smart trig class for this, a smart trig class. So cosine is positive in quadrant 1, because they're all positive in quadrant 1, and also in quadrant 4, because it says in my little a smart trig class. So those are the two quadrants where this is even possible, since it's positive here. So root 2 over, where is cosine root 2 over 2? Cosine is root 2 over 2 for pi over 4. And if you need to, you can look at your unit circle, or the first quadrant of the unit circle. Cosine is root 2 over 2 for pi over 4. So it's for pi over 4 and then any other angles that share pi over 4 as a reference angle. So what angle has a reference angle of pi over 4 in quadrant 4 though? And that answer is going to be 7 pi over 4. Because 8 pi over 4 would have been one full rotation. But we're stopping just short of one full rotation, so that's 7 pi over 4 in quadrant 4. All right, sine theta equals negative 1/2. So what quadrants is sine negative? A smart trig class. So it's negative in quadrant 3 and quadrant 4, because all are positive in quadrant 1 and sine is positive in quadrant 2. And then sine of 1/2. Think about what reference angle gives you sine of 1/2. If you need to, you can look back at your unit circle. Sine of 1/2 is when we have pi over 6. Pi over 6. But we don't want it in quadrant 1. We want it in quadrant 3 and quadrant 4. So pi over 6 in quadrant 4 is just short of 2 pi. So that would be just short of 12 pi over 6. So that's 11 pi over 6 in quadrant 4. And then in quadrant 3, it's just over 1 pi, which would be 6 pi over 6. So that's going to be 7 pi over 6 for quadrant 3. And if you have your unit circle memorized, those will be quick and easy. All right, and then the last one is tangent of root 3 over 3. So remember, A, smart, trig, class. Where is tangent positive, since this number is positive? Tangent is positive in Q1 and also in Q3. And then tangent is root 3 over 3 when you have a reference angle of pi over 6. And we can use the unit circle to help us if we want to, if you didn't remember that. So you're trying to find, sorry, my battery's low. Gotta plug in my computer. Trying to find when tangent is root 3 over 3. Remember, tangent is sine over cosine. So for pi over 6, that would be 1/2 over root 3 over 2. Flip the second fraction and multiply. So 1/2 times 2 over root 3, which gives us 1 over root 3. But I can't have an answer like that, so I need to rationalize the denominator, which is going to give us root 3 over 3. So tangent is root 3 over 3 for pi over 6, when you have the angle pi over 6, which is in quadrant 1. So that's one of our answers. And then we need to find which angle in quadrant 3 shares that as a reference angle. So that's, I believe, the same as the last one was pi over 6. So the one in quadrant 3 is 7 pi over 6. All right, and that is it for today. Yeah, thank you guys.